If you've been here before, thanks for coming back. If you're new, thanks for being here. I truly appreciate it. Uh, my name is Shantae Pitts, and I am the Learning and Development Specialist here at STEM Education Works. My job primarily is curriculum writing, and also I am the Professional Development Specialist as well. So I do help run professional development. My background is teaching. I taught for a while. I've also have a master's in curriculum writing. So I'm very passionate about STEM curriculum because that's what my focal point was STEM curriculum. So I'm going to share some stuff with you. Some of that is some curriculum that I have written as hopefully like an inspiration. I am willing to share anything you see on these slides today. So if you're like, oh my gosh, I want that, cool, let me know. I'll give it to you. If I created it, then I'm willing to share it outside of like technologies and stuff, obviously. Anyways, Shantae, please feel free to unmute if you have a question or you can type it in the chat. I do have a coworker that's running the chat for me that she will be able to answer questions as well. But also I want you to feel comfortable. This is not so formal that I don't willingly allow for people to have a communication with me while I'm doing this. It's actually welcomed. So we're going to get started. We are going to talk a little bit about unlocking test success with STEM. I'm going to talk just a little bit about, well, I guess I could show you the agenda, the relevance of STEM, if you're still processing that, which I know it kind of feels like a buzzword a lot of times. So I'm going to talk just a few of my favorite things about the relevance of STEM. We're going to talk about a few strategies. Sorry, I'm still letting some people in too. So we're going to talk about some hands-on activities that you can do. And we're also going to talk about some digital tools to use. So some robotics that you could do for helping with test prep. I'm going to also ask real quick before I get started, because I'm going to get real distracted by letting people in. Hey, Sarah, I'm going to make you a co-host so that you can also admit people. Do you mind taking over that for me so that I don't have to stress about it?
Yeah, no, I got it.
Thank you. Awesome. All right. ADHD does not work well with all of those going on at one time, as you can imagine. All right, so here we go. Again, please interrupt at any point. We're going to roll this out. So relevance of STEM. So this is probably just stuff you already know, I'm sure, but I'm still going to cover. So real world application. Obviously, STEM really does bring to life the world around us in ways that the stuff that the students are learning can be applied to future jobs or community service of some sort. It really does incorporate a lot of hands-on learning. I know when I was teaching STEM in the classroom, it was really fun to watch students who might have struggled in the classroom in general topics to actually latch onto STEM and be all about it, because it is a little more engaging for them. I also feel like it really promotes that equality, which I was just referring to that concept in education, because it opens the door to all types of learners as opposed to other things that might just focus on one type of learner because of the way that we present it. Obviously, I know most of y'all, if you're teachers, you probably are doing it a little differently because you know that just talking to students doesn't work. If you are accomplishing that, please reach out to me, because I'd be curious to know what your tricks are, because it never worked for me if I tried to lecture in my class only. So, and then it also really develops critical thinking, and it allows for students to think outside of the regular box that we think in. And really it ignites that creativity within them that I love watching. I was doing a lot of research on just like how STEM is used and where we fall in the United States when it comes to test scores. And there's been a lot of debate about that, where we fall. But the National Science Board really talks about how if you get all hands on deck, it's really going to help to just bring that knowledge up and make us a more of a stable environment in the learning environment. So with that, these strategies are probably ones that you've heard in the STEM world or even in the education world. There are these 4 strategies that are used for integrating STEM. You have the multidisciplinary strategy, which is the integration of multiple disciplines without necessarily creating a unified or interconnected approach. And then also that interdisciplinary is one, cross-disciplinary, and transdisciplinary. Those are probably ones you've at least heard one time. I know someone earlier today when I was talking to them said, oh, I've never heard of transdisciplinarian. So I am going to give you like some examples of that, hopefully to help a little bit with understanding it a little better. So you have multidisciplinary, which, for example, it might involve students working with different disciplines together to address a complex problem. It could be like energy solutions where they're working together and they all contribute their expertise, but they're not really learning about each other's expertise. They're just bringing their knowledge to the table. So they're not really digging into all the subjects. Everybody's kind of contributing. Then you have interdisciplinary, where students are like, for instance, biology, if they're doing a biology project, and engineering together, it might involve a sustainable habitat for specific species. It requires students to understand both the biological need of the species and then engineering principle behind creating a suitable environment. So that's interdisciplinary. Cross-disciplinary looks like students combining biology, mathematics, technology to analyze, let's say, model the spread of the disease in a population. All the students are bringing understanding concepts in each discipline and integrating them into developing a comprehensive solution. That's a pretty popular one. Unlike interdisciplinary education, it seeks to integrate disciplines into a unified approach. And like cross-disciplinary education focuses on exploring the connections between the relationships. And finally, this one I feel like is becoming more and more popular. And you probably are doing or have heard of it. But basically what's happening is there's a transdisciplinary STEM project involves students designing and implementing a sustainable community development plan. So for instance, this project, we require students to draw on knowledge from science, technology, engineering, math, social studies, humanities to address environmental, economic, and social aspects of sustainability. That's what that looks like. I made like lots of notes to make sure I was accurate in my explanation of it, because sometimes that can veer. If you have questions about that, please fire away those questions. But that's the gist of it. They're all amazing in their own ways, but the pull is towards transdisciplinary. That strategy is a more of a pull right now. All right, but we're really going to dig in now to understanding those hands-on and digital tools that we can use in our classroom to help with this test prep. So obviously you're here because you're looking at this or you're interested in hearing some ideas about that. I will say when I was a teacher in the classroom, STEM was still kind of a new concept, and exploring what it looks like is a lot different now than it was for me. But integrating those activities into your test prep can be a fun way for students to look at their content differently. If you haven't been doing STEM all year, every subject, it's a way to approach it differently. So here's one I've used before that I feel like has been very helpful. And this is STEM. I call this STEM as the supporting character because it's not the leading character in this review, but it is helping with the review. So its students will be given STEM challenges to complete, and the only way they're able to gain access to the materials to complete it is through answering questions correctly. So you have your test questions that you're reviewing, and then you have students who are earning the materials they need to build their STEM project. So the STEM is not actually part of the review itself. It's part of the motivator behind the review. So for example, this is a sample narrative I've used before. Unplanned and unwanted wildfires are raging through a national forest, and your team has partnered with the U.S. Forest Service to rescue local wildlife and help stop the spread of wildfires. So they're going to use the materials available and examples of types of machines to create a device to rescue trapped wildlife. It seems like a lot of information in one setting. But basically what I did is I set up an area where there was like fake fire with animals there, and they were trying to design some type of machine to save the animals. And it's set up as an intriguing interest to them in the classroom. So they're wanting to answer questions correctly so they can actually build something to like solve the issue. So the next slide is going to show you a little better kind of the concept behind the material collecting. So you have this list of materials, and you can determine how many correct answers the students need to get before they get the material. And if they need more of that, they have to continue to answer questions correctly. And once they have everything they need, then they can build their solution. So it's engaging and fun, but STEM is not what's being used as a review. It's used as a tool. That's what I mean by supporting character. questions, like I have the chat, so ask away if you have questions about this, or if you're like, actually, I don't feel like that would work. I'm willing to hear plus and negative and positive. That's what I'm looking for. Right. Then I have STEM as the main character. So this is when you're using those STEM challenges that align with the topics you're reviewing. So this one is one that I wrote a few years back. There was a standard that was about physical properties that I was trying to teach with my students, and it's really hard for them to get this concept. And I was like, how do I do a STEM activity? So I did some research and I came up with this activity. They're becoming chemists, and they're going to take what they know about properties of matter and build a brick that has high density and can withstand the most pressure without breaking. The learning target is for the students to use different materials to create a variety of bricks to analyze and record physical properties of matter. So they're mixing these ingredients together. The standard is a Texas standard. So if you don't have that standard, that's probably why. All right. So I'm going to show you this little overview of it. So you have that concept. What am I asking the students to do? And then I'm giving them the criteria to complete that. The one that I wrote for this was that they must contain at least 3 different types of material. They have to determine the mass of the material you put into your bricks mixture. So they're adding weight as they're doing it. They're listing the materials and their mass, and they're going to build 4 different types of brick with this material. Now, with this activity, it does require that the bricks kind of like harden overnight. So they're not going to be ready to go that day. So you can do this activity and then move on, because you're not going to be able to fully test it out that day. This is a sample of the student activity worksheet that I created for it. There's 2 pages, and I just kind of shoved them together for you. But they have the criteria on there for the students. This is a student worksheet. The constraints, the material choices, the data chart, and then questions that I had for them to answer. Which one of your bricks had the most density after they did the testing? So they're before the testing, they're looking at it and deciding. So I gave a little example of like an idea of what a kid wrote before is the brick didn't look like it was going to hold, and then they test it. And I just used like books, and they piled books on top of it until it crumbled. All right, before I move on, are there any questions about those little examples of ways to use STEM? Is there anything in particular that you have? Fire away. If not, we'll move to the next thing. Okay. Okay. It doesn't mean you can't still ask. All right. So digital tools. This is using technology in the classroom for using that as a tool for test prep. This is a microbit activity. Basically, the students are creating a code that is giving them times tables, which you can do different mathematical questions. When they press A, it picks a random number between 1 and 12. And then they press B, it picks a random number between 1 and 12. So it knows that they know that those are the 2 they have to multiply. And then when you shake the microbit, it gives them the answer to that multiplication question. So it really gives the kids a chance to build the code, and then they get to quiz each other with it, which is really fun. And it's a great way to do quizzing when it comes to like multiplication, which I know my students struggled a lot with that. And again, you can build that how you want to, but it's a lot of fun. If you don't have microbits in your classroom, the microbit website has a free one, a virtual one that's popped up, and it reacts just the same as a real one in your hand. So if you don't have one, it's a great way to still do it and explore and see how that works. They can't walk around with it like you can the microbit itself, but it's still a fun way to do this. All right, this one is for Sphero. So this is an activity that I found that I thought was really fun. It's really engaging and a way for exploring the solar system. So if you have to review solar system, you can use the Sphero Bolt, and create a solar system model. So the kids are getting to learn about creating a model of the solar system using multiple Sphero robots. But if you only have one, you can put different size round objects. They can analyze the model of the solar system for accuracy and inaccuracy, and they'll be able to create and execute a program in the block canvas. So this gives kids a chance to just demonstrate this Earth, Sun, and Moon system and use it to explain lunar and solar eclipse. So it's a really fun activity that they're getting to program the robots. Sometimes I feel like I can trick them into thinking they're not actually learning, which is usually great. Yes, so It's not a free microbit, it's just online. It's a virtual one. So you can literally program it and it reacts on the website. It's a lot of fun. Sorry, I'm reading the chat just to double check I wasn't missing stuff. But yes. So you just go to their website and Sarah's going to get you the link if you want to explore with that. It's a lot of fun. All right. I've also used Sphero for this, where I've placed coins, like paper coins that I've printed out. And on the bottom of the coins, there are numbers that were affiliated with a task card or a question. So they would program the robot to get to a coin, pick up the coin, and find the task card, try to answer the question. If they got the question right, they would be able to keep the coin. And they're trying to race their friends and their classmates to see how many coins they can collect. It's really fun. And again, engaging. Everyone wants to do it because they want to program the robot, but then they can't move on if they don't get it right. So it really does promote that whole, my students were very competitive and I also am. So it's a great environment of like, all right, how many did you get? I've got to get more than you. So we're racing around. And you can just use tape on the floor as a maze. You can use blocks. You can take it outside and do chalk. It's really is a fun way to do it where you're involving technology and you're involving the learning of coding without it being like so overbearing. And you can do that with different types of robots. If you don't have Sphero, if you have a different type of robot, like just coding it to get to a certain spot and trying to collect those coins or collect objects. It's a lot of fun. My students love that. This one is the STEM Challenge Treasure Hunt. This one is a little different. It does not involve necessarily STEM in the actual reviewing of tests, but it also is a way to be competitive again, like I was saying. So students are completing test prep questions, and then they receive hints about the STEM challenge they're going to do after the testing is complete. So I've told my students like, hey, we have a really fun STEM challenge that we get to do at the end of the year, but I don't want to tell you what it is. As you answer questions, I'm going to give you little portions of what it might be. And they're going to get these little hints and they glue it out and they're looking at their hints and they're trying to make predictions of what they think it's going to be. They can't get another question or another word without getting another question right. So they're like all trying to race to figure out if they can figure it out first. And, they're all hiding it from each other. They all want to know. And then I have like a really fun activity, a STEM activity that we do once we've completed our testing process. So again, STEM is not the focal point of the testing part, but it is an inspiration behind it to get them excited about the idea of testing or of finishing their testing. So this one I also really like because this is STEM, using STEM in a different way, but still using it, where the students are creating their own game or activity for the review. And so everyone's trying to come up with the best type of game or best type of way of reviewing for the state test. So I've given them right here's my narrative that I've given them, where it's, can you design a game or activity that helps you and your classmates review for the state test? Your game should cover key concepts in math, science, or other subjects relevant to the test. So sometimes I've done it where I've given out, like, you're going to do this standard or you're going to do this, and then they work together so we can incorporate more than just one game. But it requires them to do the STEM process thinking of like, what kind of game is going to be interesting to my friends? And then they have to come up with like the types of rules and how they're going to ask the questions. But it's creative and it really does make the game part of reviewing fun because the kids created their own games. So they're doing the engineering design process to build the games. And then at the end, everyone can vote on which ones they want to do. But it can be chaos, but a good kind of chaos. Okay, so I know that was very fast, way faster than I intended, but I'm used to having more people in the chat, or interrupting. So I'm going to give you a second to ask questions, or if you want clarifying things, if you want me to go back to something, let me know. Anything from anyone. This is my email address, my phone number, and then the website that you go to. For anything from here, you can reach out to me personally if you're like, I don't want to talk in this, but if you're like, I want some of the resources she talked about. I'm willing to, any of the lessons I've created, I'm willing to share because I wrote them when I was a teacher. So I have them and I'd rather somebody use them than they just sit. So